Where did life truly begin? Did it spark in the warm oceans of a young Earth, or did it arrive from the vast dark emptiness beyond our world? There's a fascinating theory called Panspermia, which suggests that life, or at least its essential building blocks, didn't start here at all. It proposes they came from the stars, carried across unimaginable distances by comets, asteroids, or even grains of cosmic dust, long before humans ever looked up and asked these questions. Imagine a frozen comet, a dirty snowball wandering silently through the void for millions of years. Deep inside, locked within its icy core, are dormant microorganisms, tiny travelers in a state of suspended animation. Then, one fateful day, that comet collides with a young volcanic Earth. As the immense heat of the impact vaporizes the ice, those hidden passengers are released into a new, fertile world. Could these cosmic voyagers be the ancient ancestors of every single living thing on our planet today? Now, Panspermia isn't about little green men seeding our world with complex life forms. The idea is much simpler and far more elegant. It proposes that the fundamental ingredients, microbes, resilient spores, or even just the organic molecules that form life, are the actual travelers. When these seeds of life land on a planet with the right conditions, like liquid water and a stable environment, they can kickstart the long, incredible journey of evolution. But could anything actually survive the brutal environment of outer space? The radiation, the vacuum, the extreme cold, it seems impossible. And yet, the answer is an incredible, resounding yes. Here on Earth, we've discovered organisms called extremophiles. These tiny survivors thrive in conditions that would kill almost anything else. They live in boiling acid near volcanic vents and even inside nuclear reactors. Crucially, experiments on the International Space Station have proven that some microbes can survive for years exposed to the harsh vacuum of orbit. If they can survive that, a journey between worlds suddenly seems plausible. Modern space missions are adding powerful evidence to this theory. NASA's OSIRIS-REx and Japan's Hayabusa 2 missions recently returned samples from distant asteroids. And what did scientists find inside? Amino acids, the essential building blocks for proteins and DNA. This is a monumental discovery. It means the raw materials for life aren't unique to Earth. The universe is apparently filled with them. The chemistry for life is written across the cosmos, just waiting for the right home to grow. Think about this. Back in 1996, a meteorite discovered in the frozen wastes of Antarctica sent shockwaves through the scientific community. It wasn't just any space rock, it came from Mars, blasted off the red planet's surface by an ancient impact. Inside, scientists found tiny tube-like structures that looked remarkably like fossilized microbes. The debate over whether they're truly signs of ancient Martian life is still fierce, but if they are real, it means that Earth and Mars may not just share rocks that travel between them, they might share a biological history. Billions of years ago, our solar system was a much more chaotic place. It was a cosmic shooting gallery with giant impacts constantly flinging planetary material out into space. Some of this debris, rock and ice ejected from one world, could have eventually landed on another. If there were microbes hitching a ride inside those fragments, they could have spread from planet to planet like passengers on a cosmic highway. It raises a mind-bending question. What if life didn't actually start on Earth? What if it just arrived here? And we can take this idea even further beyond our own solar system. Consider a star system like TRAPPIST-1, where 7 Earth-sized planets are packed tightly together around their star. If life were to arise on just one of those planets, asteroid impacts could easily spread it to its neighbors. Entire families of planets could end up sharing the same biological origin, creating a whole interplanetary ecosystem. The possibilities are staggering. As we discover more and more exoplanets that could support liquid water, the idea of panspermia becomes even more compelling. If life's seeds are constantly traveling through space, then every habitable world isn't starting from scratch. They're being seeded by cosmic impacts, by radiation pressure, by time itself. This would mean that life isn't a miraculous exception unique to Earth, but a universal process unfolding across countless worlds. We already know that on Earth, life is extraordinarily resilient. Microbes flourish in places we once thought were sterile. Kilometers below the ocean floor in total darkness, in boiling hot springs, and even in the highly radioactive coolant water of nuclear reactors. If organisms can thrive in such extreme environments here, why not on the icy moons of Jupiter and Saturn, in hidden alien oceans, or locked deep within rocks floating through the silent cold of deep space? And we have experiments that prove it's possible. Scientists have placed microbial spores on platforms outside the International Space Station, exposing them directly to the vacuum, temperature swings, and intense radiation of space for years. They survived. If they can endure a few years in orbit around Earth, it's not a huge leap to imagine them surviving a million-year journey tucked inside a protective comet, traveling between the stars. If this theory holds true, it fundamentally changes our place in the universe. It means life may not have started on Earth at all. Perhaps our true origins lie on ancient Mars, or even further away, on a world in another star system that is now long gone. It would mean that we are, in a very real sense, the descendants of cosmic travelers who began their journey among the stars. This idea changes everything. If life is not confined to our planet, then biology becomes a cosmic story. It connects us to the entire universe in the most profound way imaginable. We may not be alone, not because of visiting UFOs, but because life itself could be as common as starlight, a fundamental property of the cosmos. Future missions might finally give us the answers. The planned Mars sample return, the Europa Clipper mission to Jupiter's icy moon, and probes to Enceladus' geysers will search for life in these alien environments. If we find it, we'll face the next great question. Did life begin there independently, or did it arrive from somewhere else, just as it might have here? Panspermia doesn't just offer a new perspective on our past, it might also predict our future. As humanity begins to venture out to other worlds, we could become the agents of panspermia ourselves. Intentionally or not, we might carry life from Earth and seed it on new planets as we travel among the stars, continuing a cosmic cycle that began billions of years ago. Ultimately, this theory invites us to see life not as something rare and confined, but as a relentless traveler. It's a force woven into the very fabric of the cosmos, always finding a way to spread, to survive, and to evolve, whether here on Earth or in the farthest reaches of space. Thank you so much for watching. If you found this journey into our cosmic origins as fascinating as I do, please hit that like button and be sure to subscribe for more deep dives into the biggest questions in science. We'll see you in the next one.